Dear students, hope you are fine. Today I have a topic on returns to factor, which is also known as law of variable proportion. This law of variable proportion, it is applied in case of production sector. The production sector, where we use different factors of production to produce a particular level of output. The factors are production, land, labor, capital, entrepreneur, raw material, technology, etc. And this law of variable proportion, also known as returns to factor, it involves use of fixed factor which may be land or capital, and variable factor such as labor. As you know that land at capital, land as a factor of production, it is perfectly inelastic in supply to the whole economy. It is perfectly inelastic in supply. At capital, which is also a fixed factor, but in the short run, in the long run, it can be also varied. Its units can be changed. But in short run, it is fixed in supply. It is inelastic in supply. That is why this returns to factor, it is based on short run production function, where labor is a variable input, variable factor, land or capital is a fixed factor, fixed input of production. And when there is fixed factor on one hand and on the other hand there is variable factor, that their different combinations will yield different level of output. There will be the maximum level of output. Beyond that, adding a variable factor to the fixed factor will not give more output. It will start declining, diminishing. Therefore, the basis of this law of variable proportion, or we can say returns to factor, is law of diminishing returns. Which states that when we add more and more into a variable factor to the fixed factor, the total product of a factor, TP is total product of a factor, initially increases. This arrow shows increase at increasing rate. And then a stage comes when more units of variable input is added to the fixed input, the total product still increases but at decreasing rate. And last stage comes when adding a more units of variable input to the fixed input, such as labor to land, the total product will start diminishing, decreasing, falling, because the product capacity of a fixed factor, it is limited. Beyond that point, it will not increase. For example, on a given land, given piece of land, suppose 1 acre of land, the product capacity, the capacity to produce rice on 1 acre of land is equal to 100 quintals of rice. If we add the capacity to absorb the units of variable factors such as labor, that is equal to 10. Therefore, if we add one by one the units of labor, the total product will increase. But a point will reach when we add more units of labor, that is beyond 10 units of labor, that's 11th unit of labor, the production of rice, it will not increase beyond 100 quintals. It will start falling. The contribution will start falling because this is a fixed factor. Its production capacity is limited. The production on this land, it will not increase beyond certain point by increasing the units of variable factor such as labor. And this law, it has some assumptions. Number one assumption is labor is homogeneous. Which means that all units of labor have the same efficiency. They bears equal efficiency. And second assumption is given technology. The state of technology remains the same. There is no change in technology. On these assumptions, we will explain the law of variable proportion with the help of some example. For example, a farmer who produces rice, he needs factors of production, inputs of product such as land, labor, capital, raw material, etc. We will take the factors of production such as land and labor to show law of variable proportion. And land, in this example, it is fixed factor, or we can say fixed input, and this labor, it is variable factor or variable input whose quantity will vary with the change in the level of production. Now we will show different values of average product, marginal product and total product of factor to make this law more clear. In this table we will show the units of fixed factor, units of variable factor, labor, total product of factor, that's labor, average product of labor, marginal product of labor, and stages. The units of land, which is a fixed factor, that is equal to 1 acre. We will take it equal to 1 acre, and it will remain same throughout the production prices. And the units of labor, that is variable factor, it will change with a change in the level of production. 1, 2, 3, 4, 5, 6, 7, up to 8 units. We have changed it. And total product of labor from the different combinations is given as 5, 12, 21, 28, 30, 30, 28, 24. Average product, which shows output per unit of factor, output per unit of labor. The formula for this is total product of labor divided by units of labor. It will be 5 divided by 1, 12 divided by 2, 21 divided by 3, and so on. And this value will be 5, 6, 7, 30 divided by 5, 6, 30 divided by 6, 5, 28 divided by 7, 4, 24 divided by 8, it will be equal to 3. And marginal product is addition to total product when we use one more unit of factors such as labor. That is addition to total product by adding one more unit of labor in the production. And total product of L units of labor, which is 5, total product of L minus 1, that is 1 minus 1, that is 0, it will be 5 minus 0, it will be 5. Total product of 2 units of labor, it is 12, and total product of L minus 1, that is 2 minus 1, that is total product of this unit of labor, it is 5, 12 minus 5, it will be equal to 7, and the same procedure will be followed for these other values. Then it will be 21 minus 12, 9, 28 minus 21, 7, 30 minus 28, it will be 2, 30 minus 30, 0, 28 minus 30, it will be minus 2, 24 minus 28, it will be minus 4. Now from this data you will find that total product, it increases at increasing rate up to certain point. From 5 to 12, 12 to 21, and average product is also increasing from 5 to 6, 6 to 7. Marginal product is also increasing from 5 to 7, 7 to 9. This is the first stage. This stage is known as stage of increasing returns. I is increasing, R is returns, and in this stage the marginal product of factor, it is greater than the average product of factor. 5, 7, 9, and average product is 5, 6, 7. Therefore the value of marginal product of factor is greater than the value of average product of factor. Marginal product is greater than average product. And the second stage starts when total product is increasing at decreasing rate. It is still increasing 21, 28, 28 to 30, but at decreasing rate. And marginal product of factor, it falls in the second stage. This is the end of first stage and the starting point of second stage. From 9 to 7, 7 to 2, it follows. It is the stage of diminishing returns. These diminishing or is returns or decreasing returns. And in the second stage, the average product of factor and marginal product of factor, both are falling, both are decreasing, but the value of average product of factor is greater than the value of marginal product of factor. 7, 6, 5, 7, 2, 0. Therefore, in the second stage, the average product of factor is greater than the marginal product of factor. And this second stage ends up to the point when marginal product of factor is equal to 0, and this is the end of this second stage and the starting point of that last stage, that is third stage, in which the total product of factor, it falls, starts decreasing 30 to 28, 28 to 24 quintals of rice, as in our example. And marginal value of marginal product of factor, it becomes negative. It is known as stage of negative returns. Stage of negative returns. These are the third stages of law of variable proportion, returns to factor. And in this table we have shown the returns to factor, that is returns to labor, which is variable factor, which is employed along with a fixed factor, that is land to produce a rice, different quantities of rice. And when we calculate the value of total product, average product, a marginal product of factor, a variable factor, that will give us returns to fact, that is returns to labor, that is variable factor. That is why it is known as returns to factor, that is the return, the contribution of a particular factor in the production. When this particular factor, that is variable factor, is used along with a fixed factor. Now we will show this data shown in the table with the help of graph. On y-axis or on vertical axis, we take total product of factor, that's total product of labor, and on horizontal axis, on x-axis, we will take units of variable factor, that is units of labor. I will write L, units of L means units of labor. Based on this data, the total product is increasing at increasing rate up to certain point, then increase at decreasing rate, and lastly it falls. Therefore the shape of total product of a factor will be like this. This is total product of factor, that's total product of labor. This is divided into three stages: first, second, and third. Increasing returns, decreasing returns, and diminishing. Decreasing returns or diminishing returns, and last one is negative returns. First stage, second stage, and third stage. And here in this graph you will find that up to certain point this total product, it is increasing at increasing rate, and then onward the slope of this total product, it falls, it decreases. This point, suppose this is point A. Point A, it is the point of inflection. This is the point of inflection, which states that up to this point the total product increases at increasing rate, and beyond that the slope of this total product curve falls. And second stage starts from this combination. When we use L4 units of labor and 1 acre of land, this is the end point of first stage. That is this stage when total product is initial increasing rate, that increase at decreasing rate, and a second stage ends when total product reaches to maximum. This one, this is the end point of second stage, this when total product is maximum 30, and the units of labor employed is L6. And then the total production is 30 quintals of rice. This is the maximum production of rice when we use 6 units of labor and 1 acre of land. And this is the end point of second stage and the starting point of third stage, when total product starts falling from 30 to 28, 28 to 24. This total product curve, it is now falling. If we take this point, suppose point A, point B, point A, point B, point C. Point C shows the units of labor equal to L6, sorry, L7, and this point C on vertical x on y-axis it shows the total product of factor equal to 28. It will fall from 30 to 28. I will not draw all the points in this graph, but some important points to make it clear. Now we will show with the help of graph the average product and marginal product of factor. On horizontal axis, on x-axis, we will take units of variable factor such as labor, L, I mean units of labor, and on y-axis, on vertical axis, average product and marginal product of labor. In the first stage, the value of marginal product of labor 579, it is greater than the value of average product of factor 567. Therefore, in the first stage, the curve of marginal product of factor, marginal product of labor, it will lie above the average product of labor curve. And then it starts falling beyond a second stage from 7 to 66 to at some point it remains constant 7 to 7, then it starts falling 7 to 6, 6 to 5 to 4 to 3. Therefore this is increasing 5 to 6, 6 to 7, then constant up to certain point, then it falls 6, 5, 4 to 3, then it starts falling. Average product of labor curve. As I have told you that in the first stage the value of marginal product of labor is greater than the value of average product of labor, therefore it will lie above in the first stage, marginal product of labor curve. And then in the second stage the value of marginal product of labor, it is less than the average product of labor. It is 720, it is 765. The value of average product of labor, it is greater than the marginal product of labor. Therefore, in the second stage, it will lie below this average product of labor curve. And the end of this second stage shows that the marginal product of labor, it becomes equal to 0. This is marginal product of labor curve. Beyond this, it has a negative values, -2 and -4 as given our example. This is the first stage. And then this is the second stage, first stage. This is the second stage when marginal product of labor becomes equal to 0, stage second, and then this is stage third when marginal product of labor becomes negative, but average product of labor which is falling but still positive, falling 6 to 5, 5 to 4, sorry, 4 to 3, but still positive in the third stage. Therefore, it will lie above this marginal product of labor curve. The important point is in this graph is that when total product of factor is maximum, this 30, when 6 units of labor is employed. This is L6. Some points I will draw in this graph, not all pointers. And when we use L6 units of labor, the total product is maximum. The production of rice is 30 quintals, point B, on total product of labor curve. At the same unit of labor, the marginal product of labor is equal to 0. This is the maximum point, point B. At this point, the end of the second stage, the marginal product of labor, that is the 6th unit of labor, contributes nothing, 0, in the production of rice. Therefore, at this point, point D, marginal product of labor is equal to 0. This happens only when total product is maximum, the production capacity ends, and beyond that, adding up more units of variable factor will not yield more output. The additional factor will give 0 level of output. In this example, that is marginal product of labor, the additional unit of labor, that is 6th unit of labor, gives 0 units of production. This point is shown by point D in this graph. This is the marginal product of labor curve. This shows the marginal product of labor equal to 0, and this is only when total product is maximum, shown by this graph. And in this table, this is 30 minus 30 is equal to 0. And when marginal product of labor is equal to 0, this point is known as, this situation is known as disguised unemployment. When marginal product of labor is equal to 0, that is known as disguised unemployment, shown by point D. Beyond this,